Have you ever felt puzzled by the seemingly complex concepts of eigenvalues and eigenvectors? Then you are viewing the right video. Hi, I am Kaustubh. Welcome to my channel PhysicsBodh, dedicated to exploring fascinating concepts in physics. Yes, even the words eigenvalues and eigenvectors can sound really challenging. But don't worry, because in this video, I am going to break down these concepts of eigenvalues and eigenvectors and make them super easy for you to understand. We will embark on a captivating journey into the world of eigenvalues and eigenvectors. I will answer some of your burning questions, delve into these fundamental concepts, and uncover their significance in understanding the behavior of physical systems. So, let's get started. What is this word with letters E-I-G-E-N? It is pronounced as eigen. Have you ever wondered about the meaning and origin of this word eigen? The term eigen comes from the German word Eigenschaften, which means characteristic or a property. In the context of eigenvalues and eigenvectors, it refers to the intrinsic properties of a system that remain unchanged under a specific transformation. Now you got the meaning of the word eigen. Our next question is, what are eigenvalues and eigenvectors? To begin, let's understand eigenvectors. Imagine a pendulum swinging back and forth. When it swings in a particular way, it keeps repeating that motion without changing. This repeating motion represents an eigenvector, a stable pattern or a behavior that a physical system can exhibit. Now, let's delve into eigenvalues. In physics, we often measure properties like energy, momentum, and spin. Each of these properties has associated values called as eigenvalues. These eigenvalues tell us the specific values we can observe when we measure those properties. So, in short, eigenvectors are special vectors that only change in size when a transformation is applied to them, while eigenvalues are the corresponding numbers that inform us about the extent of their transformation, like stretching or shrinking. Now you would ask, can we have some real life examples? Absolutely. Consider stretching a rubber band. It changes its length, but its direction remains the same. This is an eigenvector. Similarly, when you resize an image on your computer or mobile screen, the image may become larger or smaller, but its orientation doesn't change. This too is an eigenvector. Our next question is, how are eigenvectors and eigenvalues related? Now let's explore the exciting connection between eigenvectors and eigenvalues. When we apply a transformation to an eigenvector, it only experiences a change in size. It gets stretched or shrunk, but its direction remains unchanged. And guess what? The extent of this stretching or shrinking precisely corresponds to the eigenvalue associated with that eigenvector. Think of eigenvalue as a stretching or shrinking factor. Our next question is, what is the role of eigenvalues and eigenvectors in quantum mechanics? To answer this, let's enter the mind-boggling realm of quantum mechanics, where eigenvectors and eigenvalues take on even greater significance. We know that quantum mechanics focuses on understanding the behavior of particles at the microscopic level. In quantum mechanics, eigenvectors are referred to as wave functions. These wave functions describe the possible states of a particle, such as its position or energy. The square of this wave function provides us with the probability of finding the particle in a specific state. The Schrödinger equation, which is a cornerstone of quantum mechanics, is an eigenvalue problem, because solving this equation enables us to determine the allowed states and energies of a quantum system. So, the wave function represents the eigenvector, while the energy values it yields are the corresponding eigenvalues. Our last question in this video is why eigenvalues and eigenvectors are so important in quantum mechanics. They are so important because they help us understand the stable patterns, the quantization of energy levels, and the probabilistic nature of quantum systems. Through these concepts, we can make predictions about particle behavior, explain phenomena like energy quantization, and gain insights into mind-bending concepts like quantum superposition and quantum entanglement. That's all for this video. Thank you for joining me on this captivating journey through eigenvalues and eigenvectors. I hope this video has answered some of your questions and ignited your curiosity about the wonders of physics. I know if you like this video, then you will definitely subscribe to PhysicsBodh. Your suggestions are welcomed in comment box. Remember to keep exploring, asking questions, and nurturing your passion for learning.